Hello everyone. So this is a question from RE-NEET 2026. In an acidic medium, 10 ml of 0.25 m oxalic acid is titrated with KMnO4 solution. If the volume of KMnO4 solution required to reach endpoint is 10 ml, the strength of the KMnO4 solution is okay. So the chapters involved is redox reactions. According to the law of chemical equivalence, gram equivalent of each of the reactant is equal to the gram equivalent of each of the product. Okay. That is, for a reaction, let's say that it is not balanced. A plus B gives me C plus D. Okay. Then according to the law of chemical equivalence, I can write gram equivalence of A is equal to gram equivalence of B, which is equal to gram equivalence of C, which is equal to gram equivalence of D. This is very helpful because we don't need the balanced equation to apply our law of chemical equivalence. Okay, so to calculate the gram equivalence of a substance, we know that normality is equal to gram equivalence of solute divided by volume of solution in liters. Okay, and we also know that normality is equal to n factor into molarity. Okay, so we can substitute this value of normality in this equation. So ultimately I will get normality, sorry, n factor into molarity into volume of solution in liters is equal to gram equivalence of solute. So this is a very important formula. Okay, and to calculate the n factor for an oxidizing or a reducing agent, we use the formula n factor is equal to modulus of final oxidation state minus initial oxidation state into number of atoms changing state. Okay, using these prerequisites, now we can solve our question. Given that 10 ml of 0.25 oxalic acid, okay, so oxalic acid is COO minus, COO minus, or you can also write it as C2O4 2 minus. Okay, so 10 ml of 0.25 molar oxalic acid is titrated with 10 ml of KMnO4 solution. Okay, so one thing we should know is that MnO4 minus and C2O4 2 minus in acidic medium, they get converted to Mn plus 2 and CO2 respectively. Okay, so with respect to reaction, I can write MnO4 minus plus C2O4 minus 2 in acidic conditions will give me Mn plus 2 plus CO2. Okay, so no need to balance this. At the end point, all of MnO4 minus would have combined with all of C2O4 minus 2. Okay, so therefore at end point I can write gram equivalence of MnO4 minus will be equal to gram equivalence of C2O4 minus 2. Okay, so let's calculate the gram equivalence of MnO4 minus and gram equivalence of C2O4 minus 2 using the formula. So we know that gram equivalence is equal to n factor into molarity into volume of the solution in liters. Okay, so for MnO4 minus, it is changing to Mn plus 2. Okay, MnO4 minus, it is changing to Mn plus 2. So let's calculate the oxidation state of Mn in both of them. So x plus 4 into minus 2 will be equal to minus 1. So x is equal to plus 7 here and x is equal to plus 2 here. Okay, so n factor will be equal to final oxidation state modulus, that is 2 minus 7 into, you can see 1 Mn is undergoing change, so therefore into 1. So this will be equal to 5. Okay, so therefore the gram equivalents of MnO4 minus will be equal to 5 into molarity is what we are supposed to calculate. So let us say it is x molar into volume is 10 ml. So therefore 10 by 1000 liters. Okay. For C2O4 minus 2, you can see it is changing to CO2. So C2O4 minus 2 is changing to CO2. Okay. So let's calculate the oxidation state of carbon in both of them. So 2x plus 4 into minus 2 will be equal to minus 2. So 2x will be equal to 6. So x is equal to 3. Here x plus 2 into minus 2 will be equal to 0. So x will be equal to 4. Therefore, n factor will be equal to modulus of final oxidation state 4 minus initial oxidation state is 3 into, you can see 2 carbon atoms are undergoing change in the reactant. So therefore into 2. So this will be equal to 2. So therefore the gram equivalence of C2O4 minus 2 is going to be 2 into molarity is 0.25 molar, which is given into 10 ml. So therefore 10 by 1000. At the end point, both of their gram equivalents are equal. So therefore I can write 5 into x molar into 10 by 1000 will be equal to 2 into 0.25 molar into 10 by 1000. Okay, so this gets cancelled. So therefore x will be equal to 2 into 0.25 divided by 5. Okay, which comes out to be 0.1 molar. Okay, so therefore the strength of the KMnO4 solution is 0.1 molar. Okay, thank you.